Hello viewers, welcome to add-on. In this question we are asked to define modulation and modulation index. So what is modulation? Modulation is a property by which we can transmit signal efficiently from one point to another point. Suppose this is our signal source. Signal source can be anything which is generating a signal. It can be a speaker or our human voice. These are all kind of signals, right? So this is a signal source. This signal source is transmitted to some receiver which is receiving our signal. So suppose when we are speaking, where the signals are received, these are received in our ear. So suppose the receiver is our ear, and in our real life scenario it will be an antenna. Okay, so a signal is transmitted from the source and it is received at the receiver. Okay, and now the distance between the source and the receiver is quite large in some scenario, right? Because sometimes we are sending a signal from 10 kilometers away, 20 kilometers away, so there is a huge gap between the source and the receiver, or the transmitter or the receiver. So between this source or the transmitter and the receiver block, there is a another block which is present, which is named channel. Now the job of this channel is to transmit the transmitted signal from the transmitter to the receiver. Now where do we modulate the signal? So the signal which is generated from the source, if the signal is a strong signal, then it will get easily received at the receiver. Okay, it will not produce any kind of distortion, or it will not do any kind of problem. But the problem arises when the signal is a weak signal. If the signal is a weak signal, during this during traveling this entire distance between the transmitter and the receiver, the weak signal, it may occur that the weak signal may get diminished, or the signal gets completely lost within some point of the channel. Okay, so then our mode or our aim of communication will be lost, because the signals we are transmitting is just diminished, right? So this is not our ideal scenario. So to make sure that whenever we are sending a signal, that signal gets received at the receiver, so in order to ensure that, we are using modulation. So by modulation we are ensuring the efficient transmitter of signal, or efficient transmission of signal from one point, or from transmitter to the receiver. Okay, so this is modulation. And this modulation, this can be done by three ways: amplitude modulation, phase modulation, and frequency modulation. So basically in modulation, what we are going to do, suppose the signal we are transmitting is just a sinusoidal signal. Okay, this is a sinusoidal signal, right? This is a sinusoidal signal. Okay, so the signal we are transmitting, suppose this is a weak signal. By weak signal I am meaning that this signal has a low frequency. Suppose this signal has a frequency of 200 hertz. Okay, so this is a low frequency signal. So in order to send this signal, we need to modulate it, and this modulation can be done by using a high frequency signal, or we can say it as a carrier signal, which job whose job is to carry this message signal from the transmitter to receiver. Okay, so this is our original message, so we term it as message signal or M of T. And the high frequency signal which is used to carry the message signal from the transmitter to receiver is known as carrier signal. So carrier signal is a high frequency signal which is used to transmit the message signal from transmitter to receiver. Okay, suppose this carrier signal has a frequency of 5 kilohertz. So of course this frequency is way greater than this frequency, so this signal is a strong signal. Okay, so what happens that whenever you are modulating the signal, okay, we are modulating the carrier signal with respect to the message signal, such that the information which is contained in the message signal doesn't get lost. Okay, so whenever you are using amplitude modulation, what we are going to do, the frequency of the carrier signal remains the same, but the amplitude of the carrier signal will change according to the message signal. Okay, for example, this is the message signal, right? This is the message signal, and this is carrier signal. Okay, this is the carrier signal. Okay, so In those regions where the amplitude of the message signal is at its peak, we will get the highest amplitude in the carrier signal, and at those points where the amplitude of the message signal is at its lowest point, we will get the lowest amplitude carrier signal. Or we can say, whenever the amplitude increases in the message signal, the amplitude in the carrier signal will also increase, and whenever the amplitude decreases, the amplitude in the carrier signal will also decrease, right? So what happens is that we are getting kind of this kind of signal. Okay, so the frequency remains the same, which is 5 kilohertz in amplitude modulation. The only thing that changes is the amplitude. So we can see at this point the amplitude is at the minimum. Okay, because in the message signal at this point the amplitude was at the minimum, but at this point the amplitude is at the highest or at its peak value, because in message signal the amplitude here was at its peak value. So here we can see the amplitude is increasing from this point to this point. So here the amplitude is also increasing from this point to this point. But as this point is reached, the amplitude again get decreased. Okay. So after this point we can see the amplitude again falls to 0. Okay. So this is the amplitude modulation in which the amplitude of the carrier signal gets modulated. Now there is another kind of modulation which is frequency modulation. In that case, the amplitude will remain the same, but the frequency will change. How it will change? Where whenever the amplitude of the message signal will increase, the frequency of the carrier will increase, and whenever the amplitude of the message signal will decrease, the frequency will decrease. Okay, so the frequency becomes like this. Amplitude will remain the same. Sorry. So then our carrier signal will be like this. So at this point, the amplitude was minimum, so the frequency was very low. But at this point, when the amplitude is gradually increasing, we can see the frequency get increased, or the gap between two cycles gets very much decreased, because frequency is inverse to time. So if we increase the frequency, the time period will decrease. So here we can see the frequency was less, so time period was more. But in this scenario, the frequency was high, so the time period was less. So in this case, as the amplitude increases, the frequency will increase, and as the amplitude will decrease, the frequency will decrease. And in phase modulation, the phase of the carrier signal will change. Okay, suppose uh, this is a message signal. So for the carrier signal will be like this here, then it will be like this. So here we can observe that there is a phase change. This phase change observed when the amplitude drops from a higher value to lower value. Okay, so this is the phase modulation, frequency modulation, and amplitude modulation, and these are the all scenarios of modulation. Okay, now modulation index we can represent it by mu. It is the ratio of AM by AC. What is AM? AM is the amplitude of the message signal. Okay, AM is the amplitude of the message signal, and AC is the amplitude of the carrier signal. So modulation index is the ratio of amplitude of the message signal and amplitude of the carrier signal, which is represented by mu. Okay, and the modulation index should have a value which is less than 1. Okay, so if the value is less than 1, it is known as under modulation. If the value is equal to 1, this is known as critical modulation, and if the value is greater than 1, this is known as over modulation. So our scenario, or our uh, useful case will be these two. Okay, when modulation index is equal to 1 or it is less than 1. So in these two cases our signal transmission will be more efficient. Okay, so this is all for this question. Thank you.